and welcome to my presentation on the environmental effects of processing plastic waste. It's well known that the buildup of plastic waste on landfill sites and in our oceans is becoming an increasingly bigger issue with every year. If I asked you to think about how this issue could be dealt with, your immediate thoughts might be recycling. However, plastic recycling comes with environmental issues of its own, and isn't the only method out there. Firstly, plastics are polymers. I will go through what that means and how they're formed, what features of polymers make plastic waste an issue, the different ways of processing plastic waste, and their environmental impact. A polymer is a large molecule, and it's made by linking small building blocks known as monomers. This process of making a polymer is known as polymerization. On the screen you can see brackets and an N, showing that this part of the structure is repeated an N number of times. This is known as a repeat unit. Here is a chemical example. Polyethylene, also known as PE, is the most common plastic in the world, accounting for roughly 34% of the total plastics market. Its monomer is ethene, and its repeat unit is shown in its chemical structure. High density PE, the picture on the bottom left, is used in rugged environments such as construction due to its dense and more crystalline structure, whereas low density PE is used in plastic bags and packaging. Clearly, the same polymer can have a range of useful applications. So how are polymers formed? There are two types of mechanism: chain growth polymerization and step growth polymerization. In chain growth polymerization, there are three main steps. Firstly, during initiation, a reactive species reacts with a monomer, generating a reactive end group. The monomer, now with the reactive end group, can react with further monomers in the same manner, increasing the chain length. This is known as propagation and continues until termination, where something happens to deactivate the end group, stopping addition of further monomers. Step growth polymerization differs from chain growth polymerization in the way that it doesn't rely on chain reactions, but instead short polymer chains produced at the start gradually join to form longer chains. This relies on two monomers with end groups that have complementary reactivity. For example, a chain might have a carboxylic acid group, while another might have an amine group, which can donate a pair of electrons, starting a reaction that results in the short chains joining together to form a longer chain. Now we know a bit about polymers and how they're formed. Why are they such an environmental issue? They're used in many products we see in our daily lives and are often extremely durable, leading to accumulation in landfill sites and in the oceans. The most common polymers have a hydrocarbon backbone, meaning they consist of very strong carbon-carbon and carbon-hydrogen covalent bonds. Think about polyethylene, which we saw earlier as an example. These stable bonds are unlikely to break spontaneously, and so polymers can take anywhere from 30 to 500 years to degrade. Clearly, plastic waste can't just be left without intervention. There are multiple ways we process plastic waste, such as recycling, incineration, and using biodegradable plastics as an alternative, which we'll learn about today. While all these methods are advantageous over simply leaving plastic to degrade, they have environmental drawbacks of their own. In general terms, plastic recycling is the process of converting waste plastic into reusable materials. There is mechanical recycling, which is used on a global scale, which involves melting plastics and remolding into typically lower grade products. There's also chemical recycling, a newer technique, in which a lot of funding is currently being placed. This involves breaking polymer chains into their constituent monomers at a molecular level, which can be used to either reform polymer chains for new products or for use in the production of entirely new chemicals. Plastic recycling has advantages and disadvantages. Obviously, the main advantage is that plastic is being reformed into new products, reducing the accumulation at landfill sites and in the oceans. Furthermore, due to the fact plastic is recycled instead of incinerated, which I will discuss on the next slide, it reduces the greenhouse gas emissions that this process would release. However, Melting plastics requires significant amounts of energy. This energy is likely to come from burning fossil fuels, which isn't exactly an environmentally friendly process. Volatile organic compounds are also released, which can react to form ground-level ozone, or smog, which contributes to climate change. So while it relieves climate change in one way, it contributes in another. Mechanical recycling can also be done only a few times before the quality of the plastic degrades. And while chemical recycling offers a solution to this issue, as polymers are completely broken down into raw materials, it requires great deals of energy, making it hard to be economically viable. Also, if fuels are produced from plastic waste and subsequently burned, the carbon dioxide emissions that recycling aims to reduce are still released. Not all plastic can be recycled, however, and therefore incineration is an alternative to sending this plastic to landfill. It involves combustion of the organic substances in waste materials, including plastics, at waste-to-energy facilities. Incineration's main advantage is that it leads to a huge volume reduction in waste, which would end up in landfill, the least environmentally friendly option. It can also burn a lot of energy, studies showing that it's more energy dense than coal, even when contaminated with substances often found in waste such as moisture. Nevertheless, the ash found in incinerators can be a big source of pollutants, such as dioxins, nitrogen oxide, and particulates. As mentioned previously, nitrogen oxides can react with volatile organic compounds given off by recycling. They are also expensive to build, therefore it's questionable whether money should be invested in this scheme or simply more recycling plants. It would also naturally lead to a reduction in recycling, and therefore new plastic products would have to be formed as replacements. Biodegradable plastics are made to be compostable and are able to be broken down by the action of living organisms such as microbes. They're usually plant-derived, coming from renewable materials such as cellulose and polylactic acid. Polyethylene is said to be the most problematic plastic that is resistant to microbial attack. Therefore, it's in our best interest to make a biodegradable alternative. It's resistant to biodegradation for the same reasons as discussed earlier, being the highly stable carbon-carbon and carbon-hydrogen bonds. However, this problematic polymer backbone is altered by adding a carbonyl group, a carbon-oxygen double bond. This allows it to undergo a mechanism known as biotic oxidation and can be triggered by biotic and abiotic factors. Their main advantage is obviously the fact that it tackles the principal issue that plastics present, being that they are resistant to biodegradation. Biodegradable plastics also come from renewable materials, which is more sustainable than the fossil fuel alternative. However, they aren't the perfect solution that we would like to think they are. Firstly, there's an ethical debate over whether arable land should be used for bioplastics or food growth. Moreover, even if bioplastics are mass-produced, their ability to compost is nowhere near that of regular plant matter, and would require very energy-consuming industrial-level composting to be done as fast as we would like. After discussing the different ways of processing plastic waste, can we come to a definitive conclusion on the best method? Sadly, not really. Plastic waste itself is an environmental issue. However, in trying to solve this one issue, we end up risking worsening other global issues, such as climate change. Arguably, the best solution would be to reduce usage and disposal of plastics altogether. Thank you for watching.